Hello friends, let us go to the next topic in fluid mechanics. This topic is boundary layer theory in various university examination related to mechanical and civil engineering. Also, in the gate examination, it has a good weightage. Let's talk about boundary layer theory. Now, when we are talking about fluid, which is moving with velocity u infinity. Suppose there is a fluid which is moving with velocity u infinity and it is not having any contact with the surface. The surface means we are talking about any solid body. Now, what will happen? The velocity of this fluid will be constant. So, if we measure the velocity in y direction, as per our notations in the Cartesian coordinate system, this is positive x direction and y direction. So, if we measure the velocity along the y direction at various points when the fluid is not having any contact with the solid body or solid boundary, what will happen? The velocity will be constant, and at any point, the velocity will be equal to u infinity. Now, this uh, is called as a free stream. So, if we talk about this free stream, the velocity is constant. It means that the value of du by dy, because we know the Newton's law of viscosity, which states that the shear stress is proportional to rate of shear strain or the velocity gradient in y direction. So if we talk about this du by dy, that is velocity gradient in y direction, so this value will be equal to 0. As we are saying that velocity is not changing, it means that the value of shear stress will be equal to 0. So there will be no shear stress if the fluid is having a free stream. Now this will continue till the fluid does not experience any solid body or solid bond. Now let us say, suppose there is a plate, horizontal plate in the direction of the fluid flow. So suppose this is a solid plate of certain length. Suppose this is the uh, capital L is the length of the plate. We talk about the length along x direction, and this is the y direction. Now, before the plate, when the fluid is not having any contact with the body of the plate, the fluid will act as a free stream. The fluid will not have any change in its velocity, and the shear stress will be equal to 0. Now, as the fluid comes in contact with at this point, the fluid will start to have contact with the plate surface. So, this point is called as the leading edge. This is the leading edge, and uh, the fluid, we say that it is different layers which are arranged one above another. So the layer which is in contact with this uh, solid plate surface, because of the forces, the velocity of the fluid will slow down, velocity of the fluid will reduce, and it will be equal to 0. So at the surface, the velocity of the fluid will tend to zero, and suppose u is the velocity of the plate, sorry, u is the velocity of the surface fluid, so that at the plates u will be equal to 0. Now this is because of the forces that the fluid layer experiences. There will be adhesion force because of the different molecular structure. There will be van der Waals attraction forces, and because of that, the velocity will be equal to 0 at the surface. As we go upward in the upward direction, what will happen? The velocity will steadily increase. The velocity will be uh, now, if we draw the velocity profile along the y direction, so at the surface, as we said, u equal to 0, and as we go in upward direction, the velocity will go on increasing because the effect of the plate, because of the forces that are experienced by the various layers in the y direction will be intensity will be less, and the velocity will be at one point the velocity will be equal to the free stream velocity. So at this point, at some value of y, the velocity u will be equal to 0.99 times the u infinity, or we say it will be nearly equal to the free stream velocity. So what we understood here, as we go in the y direction, at any point along the length of the plate, we will find that the velocity will go on increasing, and at some point, at some location, at some value of y, the velocity will be equal to the free stream velocity. Now, what we do, we'll try to find out the locus of various points. The velocity uh, is equal to the free stream velocity. So, so this is the plate. Suppose uh, suppose this is x1 value. At this point, uh, this dot represents the distance where the value of velocity equal to the free stream velocity, and at this x2, uh, at this point, the velocity equal to the free stream velocity. So for different values of x, we find out the values of y where the velocity will be equal to the free stream velocity, and we draw a curve, or we draw a profile connecting all those points, and this profile is called as the boundary layer. Boundary layer. Now, friends, this boundary layer is easily visible, or we can physically observe the boundary layer. There are many videos available on various YouTube uh, channels, so where you can see the experiments they have conducted, where the boundary layer is visible. Now, when we had a discussion about the free stream velocity, we said that the value of du by dy equal to 0 in the free stream. So this is the free stream, and du by dy was equal to 0. It means that tau was equal to 0. Now, in the boundary layer, what is happening? The value of du by dy is not equal to 0. It means that the shear stress will have some value. Okay. There is a relative motion between the layers inside the boundary layer, and outside the boundary layer there is no relative motion. Or in other words, we can say that the relative motion, the intensity of relative motion inside the boundary layer is very high, and intensity of relative motion outside the boundary layer will be very small, so that we can uh, neglect it. Now, as you can see here, the thickness of the boundary layer, as the value of x is increasing, here you can see that we are getting this y1 if we say, and at this point we are getting this value as y2, and y1 is smaller than y2. So what is happening, as we go on increasing the value of x in the boundary layer, more fluid is added from the outside of the boundary layer. So what is happening? The thickness of the boundary layer is going on increasing. So we can say this m quantity of the fluid is being added inside the boundary layer as we go on increasing the value of x. So uh, the boundary layer thickness, if we talk about the boundary layer thickness, the notation is delta boundary layer thickness can be said to be a function of the value of x. As the value of x is increasing, the boundary layer thickness is also increasing. Now, in fluid mechanics, we talk about the laminar and turbulent flow. The same thing is happening here. We can differentiate the flow by using the Reynolds number. So Reynolds number for flow over a flat plate is Reynolds number is equal to density into the free stream velocity into the value of L divided by mu. So Reynolds number is changing with respect to the value of L, or with respect to this L is nothing but the value of X. So as the X value is changing, the value of Reynolds number is increasing. Now the critical value of Reynolds number, uh, if the value of Reynolds number is less than 5 into 10 raised to the power 5, we say that the flow is a laminar flow, and if the value is more than 5 into 10 raised to the power 5, we say that it is a turbulent flow. And for satisfying this condition, whatever the value of x we get, at that value of the x, we get the critical Reynolds number. So now let's draw our boundary layer diagram. So here, suppose at this value of x1, we are getting Reynolds number critical. So till this value, the flow will be the laminar flow. After this, up to certain region, certain value of x2, the flow will be the transition region. It will be converting into turbulent region. Okay. And after the value of x2, the flow will be turbulent flow. So here the flow will be turbulent flow. Now friends, this is related to the introduction of boundary layer. We had a discussion regarding the boundary layer and the value of critical Reynolds number. We had discussion about the free stream velocity and how the variation of the shear stress inside the boundary layer and outside the boundary layer, and the factor on which the boundary layer depends. In the next session, we'll talk about the various boundary layer thicknesses, that is displacement thickness, momentum thickness, and energy thickness. I hope that you are watching the video contents which are available on our YouTube channel. If you are happy with the content, please subscribe the channel. If you want some content related to another topics, please post it in the chat box. Thank you, friends.